So the first point we looked at was oligodendrocyte regeneration, which is important for myelination. The next point we're going to look at is remyelinations. Remyelination, which is important because we know that we have demyelination in MS. So initially, neurons adapt to demyelination by redistributing the ion channels. So where you have some minor remyelination, you'll have a higher concentration of ion channels at that nodes of Ranvier, so it can compensate for the loss of electrical current. But eventually, the demyelination becomes so severe that we can't compensate and we lose the signal. And as I suggested before, as I expressed before, that research shows that remyelination can only occur within a short time period. You need to have a constant reproduction of mature oligodendrocyte cells because they can only recreate myelin for a short period of time. So I'm just scrolling up. So the impact of exercise on remyelination in injury models of MS has not been extensively studied, and to date there's only one study that has been produced. So this review article doesn't only use MS models because sometimes there's a paucity of research. It also looks at other neurological models to support its argument. So it goes through models of Parkinson's disease, Alzheimer's disease, stroke, and spinal cord injury, and sometimes peripheral nerve injury. But I'm going to try and focus as much as I can on just the MS examples. So this study was conducted in 2018. It examined the effect of voluntary exercise on remyelination in an 8 to 12 week old female with lysolecithin-induced demyelination. So this is demyelination induced in the spinal cord. It showed that 14 days post-lesion, there was significant increases in MBP, which is, again, that's the differentiation cell required to turn OPCs into mature oligodendrocytes. It significantly improved the density of remyelinated axons and the thickness of newly generated myelin. So we didn't just have a band-aid repair here. We had good quality, thick remyelination. So the density of remyelinated axons, as well as the thickness of newly regenerated myelin, was improved in these exercise models of mice. Lesions isolated 5 to 10 days post-lesion determined. Okay, so this is an interesting fact, but it's pretty complicated for me to explain. So I'm just going to go on to this next point here, which is really important. That so this is really cool point that they said. In this article, they found that remyelination achieved in exercising mice. So remember, this is the one study that they have in MS models of exercise and remyelination. So they found that remyelination achieved in exercising mice was of equal magnitude to that elicited by the medication of remyelination, clemestine. So clemestine is an over-the-counter antihistamine that has been shown to improve remyelination in some human models, but most of the studies are done in animal models. But the point is that exercise improved remyelination to the same degree as the medicine, and even better, when the medicine and exercise were combined, there was a synergistic effect. So there was an even better effect of remyelination. So we've gone through oligodendrocyte proliferation, remyelination,